Hey, hello, good evening. And in this session, we're going to discuss some questions on hyperbola and also the most important part that if you have a line segment which meets any 2-degree conic, then we need to find the length of the chord. So let's see this. So the length of chord intercepted by a line on a 2-degree conic. So for simplicity, we'll consider the conics which does not contain xy term. Okay, of course, you can solve this even for xy term, but it will be a bit cumbersome task. Now, what do I mean by this? So let's say I have a 2-degree conic here. Say it's any 2-degree conic. And say I have a line having slope m, and this meets the curve at 2 points. So the point A and B. Now let's imagine the coordinates of point A are nothing but x1, y1, and B is nothing but my x2, y2. So I'm given a 2-degree conic and I have my line, say Lx plus My plus N is equal to 0. We can take this. Now our goal is what? So goal is to get length AB. So I want the length of AB. So for length of AB, of course, we can directly see that there is a distance formula here, because most of us, what do? We take the line and then solve with the curve and then get these 2 points A and B. Then we get the length of AB by using the distance formula. However, if we apply some little bit of theory, then we see that this is nothing but x2 minus x1 square plus y2 minus y1 square. And if we noticed here, so if I take x2 minus x1 out from this square root, so this will become modulus of x2 minus x1 rather, and this will be what is square root of, this is 1 plus, this guy will turn out to be y2 minus y1 over x2 minus x1 square. And if you watch this thing carefully, then this we have been seeing since the beginning of our school here. Okay, school means 10th standard, of course. So x1 minus x2, or you say x2 minus x1, does not matter. And this is nothing but y2 minus y1 over x2 minus x1 is nothing but the slope of this line. So we can add on here 1 plus m square. So the length of chord, so the length of the chord, okay, AB is going to be simply modulus of x1 minus x2 into square root of slope of the line square. This is very powerful, in fact. Now, the question would be, how do you find this x1 minus x2? So we have this line to find mod of x1 minus x2. We put the line equation into the conic. We put the line equation in to the conic in the form of x. So in the form of x to get a quadratic, because it's a 2-degree conic, so we get a quadratic equations to get a 2-degree equation. I'll say the equation is ax square plus bx plus c. Now this is going to have 2 roots here, but that's a chord, so say x1 and x2 are my roots. Now I want x1 minus x2. So x1 minus x2 would be simply what? We can add on here x1 plus x2 square minus 4 times x1 into x2. So if you watch carefully, then x1 plus x2 square is minus b over a square minus 4 times product of the roots is c over a. So this turns out to be b square minus 4ac over a square. So this is mod of x1 minus x2 square. So therefore, mod of x1 minus x2 would be simply square root of b square minus 4ac over modulus of a. This is nothing but my difference of roots. So I can just get the difference of roots here and then just simply plug in here. This would give me the length of the chord. Okay. Now let us see some problems based on them. So suppose we have this problem. The line x minus y plus 1 meets the ellipse x square plus 4y square is equal to 3 at 2 distinct points A and B. The length of the line segment AB is what? So you imagine that this is my ellipse, x square plus 4y square is equal to 3, maybe like this. And I have a chord here. Okay, this is my line. x minus y plus 1 is equal to 0. So we can write down here y is equal to x plus 1. This is my line. Now slope is what? 1. So now we'll just plug in this line into this equation because ultimately we know the length of chord is this is A point and this point is B. It's going to be mod of x1 minus x2 into square root of 1 plus m square. So m is 1. That means length is going to be simply root 2 times mod of x1 minus x2. That means now my entire focus is shifted to finding the difference of these roots. So for this, what we will do, we'll just plug in y is equal to x plus 1 into this equation. So we get x square plus 4 times x plus 1 square is equal to 3. We need to open this. So x square plus 4 times, this will be x square plus 2x plus 1 is equal to 3. So 5x square and then 8x and then 4 plus 4 into 1. 4 minus 3 is plus 1 is equal to what? 0. So here this will have two roots, say x1 and x2. So mod of x1 minus x2 is going to be square root of, by this formula we have seen here, square root of b square minus 4ac. So square root of b square minus 4ac would be, what is b by the way? Yes, 64 minus 4 into 5 over modulus of a, which is 5. So I get here 64 minus 20, which is 44 by 5. So therefore length is going to be square root of 88 by 5. So we can multiply root 2 inside and we end up getting square root of 88 over 5. This would be the length for sure. So here you don't have to find the point of intersection and all. We can directly do it. Because here if you go and find out the point of intersection would be a bit irrational, and then applying the distance formula would be a bit cumbersome task. Let's go for the next one. So you have line 2x minus y plus 3 meeting the parabola y square minus 3y plus 2x minus 24 at two distinct points A and B. So we want the length of the line segment AB. So it's again the same part. So I have a parabola here and this is my chord, which is y is equal to 2x plus 3. Now this meets the parabola. So we can add on here 2x plus 3 square minus 3 times 2x plus 3 and then plus 2x minus 24 is equal to 0. So when I open this, this would be 4x squared plus 3 into 2, 6 into 2, 12x, and then plus 9 minus 6x minus 9 plus 2x minus 24 is equal to 0. So this 9 and minus 9 gets incorporated, and then I'm left with 4x squared. 12 minus 6 is 6 plus 2 is 8x. 8x and then minus 24 is equal to 0. So this gives me x squared plus 2x minus 6 is equal to 0. Now I need to find out the difference of roots here. So length of the chord, I'll find out better x1 minus x2. So it's going to be square root of b square. So 4 minus 4 AC means 24 over modulus of a, which is 1. This gives me square root of 28, which could be written as 2 root 7. Now, so length of the chord AB would be modulus of x1 minus x2 into square root of 1 plus m square. So this gives me square root of 1 plus m. M is 2. So I get here 1 plus 4 times 2 into root 7. So this gives me 2 times the square root of 7 into 5 is 35. So my answer would be 2 times the square root of 35. Let's go to the next. So this is a problem on the hyperbola. So let the sum of the focal distances of the point P4, 3 on the hyperbola be 8, root 5 over 3. For S, the length of lattice rectum is L and the product of focal distances of the point is M. So we need all these points. Okay, let's go ahead. So the sum of focal distances of the point P4, 3. So let's take the hyperbola here. Suppose this is my hyperbola, like this. And this is the directrix here. This point is 4, 3 here. So this point is 4, 3, and that's how the focal distances is given to be this. So sum of focal distances basically, that means I want, this is my point S and this is S dash. So this distance is given to me. That is SP plus S dash P. is given to me, that is 8 and then square root of 5 over 3. So I need to find out the focal distance basically for this. So let's go ahead. So we want the focal distance, that is SP. So we have this line which is going to be A by E. We do not know what it is. And this is minus A by E. So let's go ahead. We'll apply the focus directrix property. So I'll be using SP is equal to E times PM. So M is nothing but the distance from the directrix. So this is going to be my PM. So I want my distance PM. So PM is going to be simply what? E times PM if I want. That means I want this distance. This distance I want, the yellow part. So this I can see clearly. That means from 4, if I remove A by E distance. So from 4, if I remove A by E distance, I get my standard thing. That means it's going to be 4E minus A. So SP is going to be this. So therefore S dash P will be, now A will be added here. So I get here 4E minus, no, plus A. So I'll be adding here. So I get 8E is equal to 8 times root of 5 by 3. So this 8 and 8 gets cancelled. I get E is equal to square root of 5 by 3. Now we want the length of lattice rectum. And I know my point, this 4 comma 3 lies on the hyperbola. So since 4 comma 3 lies on the hyperbola, we can say lies on the hyperbola. So it will satisfy the equation. So I'll be having 16 over a square minus 9 over b square is equal to 1. So I'll take this one here. Now eccentricity is given to me, so I'll go for squaring this. So e square would be simply 1 plus, and since this hyperbola is the standard one, so we get here b square over a square. Now let's square this. So from here, I'll be having e square as what? 5 over 3 is equal to 1 plus b square by a square. So from here, I get b square by a square is equal to 2 by 3, 5 by 3 minus 1. So b square over a square I need to find out. So we'll do one thing. From here, we'll try to get one equation. So 16 over a square is equal to, we'll transfer this to that side. So I get 1 plus 9 over b square. So this, if I see here, then I get 16 over a square plus b square plus 9 over b square plus this is equal to, so let's write on there equal to. So I want b square over a square, so I'll transfer this one here, this one there. So I get b square over a square is equal to b square plus 9 over 16. So I can transfer this one here. So this gives me b square plus 9 over 16 is equal to 2 over 3. So this gives me 3b square and then plus 27 is equal to 32. From here I get b square is equal to 5 by 3. Now b square is 5 by 3. So what do we need? We need a square then. So we can get a square also from here. So let's go ahead on removing all these stuffs. So b square is 5 by 3. So b square is equal to 2 by 3 times a square. So b square would be, oh, sorry. I should have written in a because we want to find out a square basically. So let's go ahead. And now a square would be 3 by 2 times b square. So this would be 3 by 2 times b is 5 by 3. So 3 gets cancelled. I get my a square is equal to 5 by 2. So we got a square also. What do we need now? Length of lattice rectum is L. So length of lattice rectum we'll find out. So length of lattice rectum is going to be L here. So the length of lattice rectum is L. Let's find out the length of lattice rectum. So length of lattice rectum would be 2 times b square over a would be 2 over a. A will be root 5 over 2. B square is how much? B square we have written directly. That's 5 by 3. So B square is 5 by 3 from here, and A square is there. So B square will be 2 times 5 over 3, and then upon A. Anyway, we want length of the lattice rectum to be squared. So I guess there is no point of writing all these things. So better we will write down here. This is my length of lattice rectum, L. So this need to be squared. So L square will be equal to 4 times B to the power 4 upon A square. So 4 over A square is going to be 2 by 5 here. And then into B to the power 4 is going to be 25 by 9. So 5 5's gets cancelled. So I get uh, 40 by 9. This is going to be my length of the lattice rectum square, and then the product of focal distances of the point E is M. So we want the product of focal distances. So the product of focal distances means I'll find out here. This gives me product of focal distances. So we know it's going to be simply what? Um, Focal distances is SP into S dash P we want. So and SP into S dash P we can find out. This is nothing but what? We already have written it's 4 minus A over E. So 4 minus A over E into 4 plus A over E. So it's going to be 16 minus A square by E square. So let's write down there. So 16 minus A square is 5 over 2, and E square would be 3 by 5. This 5 gets cancelled. So I get 32 minus 3 will be 29 over 2. So this is my product. So say it is M. Now we need a 9L square. So 9L square will be 40, and 6M will be, this will be 6 into 6, 29 into 3, 78. So now we want 9L square plus 6M is equal to 70 plus 40, 110 plus 118. So we get 118 here. There is no option matching here. So thanks, some error is there. Okay, let's find out. So this seems to be fine here because there is no error here. A square and B square. Hmm. I guess it's into S test space. Focal distances. Oh, okay. We missed here E square. Here we missed. But that's product. No? So E times 4 minus 0. So E square we missed. So E square would be here. That means I'll be having here. This part would now become 16E square minus A square. So 16 into E square is going to be 5 by 3 minus A square is 5 by 2. So this is 80 by 3 minus 5 by 2 will give me 160 minus 45 upon 6, which is, oh, sorry, not 45, 15. 5 into 3 is 15. So this will be 15. So this gives me 145 over 6. So M will be this. So 6M would be 6M would be now 145. 6M would be 145. Now what we need is 9L square. So 9L square plus 6M would give me 40 plus 145 will give me 185. So the answer would be 185. And that makes option, yeah, D correct. Okay, let's go to the next one. So here we have eccentricities of the ellipse, this and this respectively, and B is less than 5 and even E2 is 1. Then the eccentricity of the ellipse having its axis along the coordinate axis and passing through all 4 foci. Okay, 2 of the ellipse and 2 of the hyperbola. So we can imagine it's like this. Now since B is less than 5, so this implies B square will be less than 25. So this ellipse, that means b square is bigger. That means ellipse is like this somewhat. So this ellipse we have, and then we have an hyperbola, and this is 16. So this part is basically 0 comma 5 here, and this is 0 comma minus 5, and this is going to be b here. It says b is less than 5, and we have here this guy's 4. That means my hyperbola would go somewhat like this. So we now have uh, points. This is going to be the foci here, and this is another foci for hyperbola, and foci for the ellipse is going to be here and here. So now we are looking for an ellipse which will pass through all these foci. So this ellipse I'm looking for. I want the eccentricity of this ellipse, the blue ellipse. So let's go ahead. Hmm. So eccentricity of this ellipse we can find out. So eccentricity even is going to be even square is equal to 1 minus. Since the ellipse is this one, that means I'm going to have here b square by a square. So a square by b square it's going to be. So b square by 25 I'll get. And for e2 square, I'm going to have here, this is hyperbola. So I get here 1 plus a square, b square over a square. So I get here b square over 16. Now, since it is said that even into e2 is 1, so that means even square into e2 square is also 1. The square is also 1. That means I can multiply this. So 1 minus b square by 25 into 1 plus b square by 16 is equal to 1. So we need to solve them together. So that means if I want to get this big, this should become the 1. That means if I take the reciprocal, so 25 minus b square over 25 into 16 plus b square over 16 must give me 1. So if I want this to be 1, that means this quantity will be equal to 16, and 16 plus b square must be 25. So 25 minus something should give me 16. So that means b square should be 9. So we have got b square is equal to 9. That means I know now both the eccentricities. So even is going to be 1 minus 9 by 60, 9 by 25, which is 25 minus 9 is 16. So we get here 4 by 5. This is my even, and E2 is 5 by 4. So we have got the eccentricities. Now what do we need? So we basically need these foci. So foci is going to be what? So we need a square and b square there. So even square is going to be 1 minus b square. Oh, sorry. The foci is going to be, for this guy, it's going to be 0 comma be. So 0 comma b into e is going to be the foci plus minus. So this implies we get here 0 comma plus minus b. B is 3 and even is the foci for the ellipse. I'm sorry, eccentricity of the ellipse. So even, that means even is here 4 over 5. Okay, then this will be not b then. 0 comma b, so I'm going to have 5 here. So this is now b actually. So this 5 gets cancelled. So we get here 0 comma plus minus 4. So we get the foci here and the foci of ellipse. And the foci of hyperbola is going to be plus minus a e2 comma 0. So I'm going to have plus or minus a. A is here 4. So 4 into e2 is 5 by 4 comma 0. So I get here plus or minus 5 comma 0. So this is the foci of hyperbola. Now we want the eccentricity of ellipse, which is passing through here. That means I want this point and this point. So this will form uh, E of the ellipse square is going to be 1 minus. This ellipse is like this. So we need to see here which one is bigger basically. So if I consider, then I know my ellipse is like this basically because this point is 5 comma 0. This is minus 5 comma 0. This is 0 comma 4 here and 0 comma minus 4. So my ellipse is uh, 1 minus b square by a square. So 16 by 25 will give me 9 by 25. So therefore, eccentricity of the ellipse will be 3 by 5. Let's go for the next one. Yeah, so here we have So let one focus of the hyperbola be root 10 comma 0 and the corresponding directrix bx is equal to 9 over root 10. So E and L are the eccentricity and the length of the lattice rectum. So we need all those stuffs. So let's go ahead. Focus of the hyperbola. So the hyperbola is standard given here like this. So this focus is given to be root 10 comma 0. That means I know its AE is equal to root 10 and directrix is 9 over root 10 given. That means A over E is equal to 9 over root 10. So I can plug in here A or E in the form of both, but ultimately we need both of them. So either I'll think of plugging E here. So E will be from here I get um, A is equal to 9E over root 10. And from here I get just plug in here in this equation. So I get 9E 9E over 9E over root 10 here. And then this is again E will be equal to what? Root 10. So E square is equal to 10 by 9. So E is equal to root 10 by 3. That's what we get eccentricity. And then once we got this thing, so we know what is going to be my A. So A is equal to 9 by root 10 and E is root 10 by 3. So this 10 gets cancelled. I get A is equal to 3. So A is 3. That means now I need a B somehow. So of course we can use the eccentricity concept. So E square is equal to 1 plus B square over A square. So E square will be what? 10 over 9 minus 1 is equal to B square. And A square is again 9 here. So 10 minus 9 would be 1 over 9 is equal to B square over 9. So from here I get B square is equal to 1. So this gives me my B square is equal to 1. So once my B square is 1, what do I need basically? I need the eccentricity. So eccentricity I have got, and we need a length of lattice rectum. So length of lattice rectum is going to be 2 times B square over A. So 2 over what is A? 3, and then B square. B square is simply 1. So I get here 2 over 3. So from here I get 9 times E square. E square is 10 over 9 plus L. L is nothing but 2 by 3. So I'll multiply this by 3 and this one also by 3. So I get 9 getting cancelled and 3 into 2 is 6 plus 10 is going to be 16. Here is, yeah. So we have the foci of hyperbola with 1 comma 14 and 1 comma minus 12. If it passes through the point 1 comma 6, then the length of its lattice rectum is what? So this is 1 comma 14 and 1 comma minus 12. So we can think of the hyperbola like this. This is the foci. So 1 comma 14 must be here, and then 1 comma minus 12 is going to be here. So all the formula of length we can apply even if our coordinates are changed. So we don't have to worry about anything. So the directrix here. Now let's see. So the distance between the foci is going to be what? 2AE is equal to 14 plus 12 is 26. So from here we get A into E is equal to 13. So I'll call this my equation 1. Now also says the given parabola passes through 1 comma 6. So 1 comma 6 is somewhere, let's say here. So we can apply this concept, that focal distance concept. So from this focal distance concept, we know that SP minus S dash P is equal to 2A. So SP minus S dash P is going to be 2A. So from here, we get to see SP minus S dash P, we can get this. Okay. So point S is given to be 1 comma 14 and this is 1 comma 6 here. So SP is going to be we'll get A from here. So SP is going to be square root of 1 minus 14 minus 6 is 8 here simply. And then no 8 square. So ultimately we get 8 here. So S dash P is equal to again square root of this is 1 gets cancelled 6 minus 12 6 minus 12 is going to be 18 square. So I get here 18. So that means I get mod of 8 minus 18 is equal to 2A. So 8 minus 18 is 10. That means A is equal to what? 5. So A is 5. I can plug in here. So E will be 13 over 5. So once we have got is equal to 13 over 5, that means we can now get uh, length of lattice rectum. So the length of lattice rectum would be what? 2 times b square over a. So we need b square basically. So b square in this case would be what? E square is equal to 1 plus b square over a square. So we can add on here a square directly instead of writing in the denominator. So I get this. Now a square e square will be 169 minus a square will be 25 is equal to what? B square. So 169 minus 25. 9 minus 5 is 4. 6 minus 2 is 4. And then 1. So we get here 144 into 2 by a is how much? 5. So we get 288 over 5. So this is the length of lattice rectum. Let's go for the next one. So we have a hyperbola having one of its foci at minus 3 comma 0. If the lattice rectum through its other focus subtends a right angle at the point P, then and some a square b square is given to be of this type. So we need alpha plus beta. All right. So we have a hyperbola like this here. And since the focus is minus 3 comma 0, that means hyperbola must be on the x-axis. That means the transverse axis is going to be here, the x-axis. So this is my minus 3 comma 0. So of course the next focus should be 3 comma 0. Now this is my point P given and the lattice rectum here. So lattice rectum is definitely here. And now it is said that this subtends angle 90 degree here at point P. That means if I draw these two line segments here and one of them here. So this is going to be 90. That means half of it's going to be 45, 45. Now what do we need is A and B we want basically. So no problem. I know at least my A into E is 3. So this we know. And 2AE is equal to 6 we know. Of course, that's what AE we get. Okay. So 2A is 6. So there is no point of getting this thing, or else we'll write it. A is equal to 3. We'll use it. A is 3. Now, since this is 45, so I know my this angle. This is semi-lattice rectum. And this one I know. So semi-lattice rectum is going to be what? Lattice rectum 3 is at the focus. Okay, no issues. Let's go ahead. So tan 45 will be semi-lattice rectum, opposite or adjacent. So this is going to be what? 6. So semi-lattice rectum is b square over 6a. So from here we get b square is equal to 6a because tan 45 is 1. And this is semi-lattice rectum, so b square over a. Now, anything else given here? Yeah, we'll use this condition. So a square e square is 3. So a square e square will be 9 then. Since a is 3, so we're squaring this. Why? Because a square e square we know. So e square is equal to 1 plus b square over a square. We'll transfer this. So we get a square e square is equal to a square plus b square. Now a square e square is 9 is equal to a square plus b square is 6a. That means from here I get a is equal to. So a square plus 6a minus 9 is equal to 0. Rather, I should have kept it here because I feel that this quadratic is easy to handle. We'll write down here plus 9 and we'll write here also plus 9. So we get a plus 3, the whole square is equal to 18. So a plus 3 is equal to plus or minus the square root of 18 will be 3 root 2. So a is equal to minus 3 plus 3 root 2 and second one is minus 3 minus 3 root 2. So we got both of them. Now what do we need? A square. Okay, we'll see it. So first let's find out b square, then we'll find a square. So b square is required. So b square is 6 times a. 6 times a, we can take any of them. So minus 3 plus 3 root 2 because ultimately this is going to be, no, nothing is mentioned. Okay. Alpha and beta are natural. Okay, what do we get? Nothing. Okay, let's see. What do we get? A plus 3 square is 18. So a plus 3 will be plus or minus 3 root 2 and a is this. Okay, let's find out and see which one do we get. because it might happen that for this A or for this A, they might have given the options, but it might not be given. Let us see which one is there. I don't have the options here ready. So this gives me minus 18 plus 18 root 2. This is b square. Or if I take b square to be the second one, so I end up getting b square to be, or b square is equal to 6 times a if I take negative. So I get minus 3 root 2. So this gives me minus 18 root 2 is b square. Now a square we have, no, we'll square it. So a square would be, we can simply square them. So a square is, okay. So it does not matter even if I square this, because ultimately I get, uh, no, I don't get, because this will give me plus, this will give me minus. So we'll do one thing, whatever we have taken, we'll square this one here. So I get 3 plus, sorry, 9. So corresponding to this one, the one which we have taken minus 3 plus 3 root 2 a. So if I get a square, then a square would be 9 plus 18 will be 27 minus 18 root 2. This is my a square. Or if I take this one, so I get a square is equal to 27 plus 18 root 2. So these are the two choices for us. B square, this one, and corresponding to this, we have here a, and the same story here. Now we need a square into b square. That means this part needs to be multiplied. So a square into b square will be, now we simply need to multiply them. So this looks a bit terrible. Okay, so we see that we can take 18 common. So I end up getting minus 1 plus root 2. And here if I take 9 common, so I get 3 minus 2 root 2 is my a square into b square I want. So we have multiplied it here. So this gives me 18 into 9 is 162. And now we'll just simply multiply these two inside. So I get minus 3 minus plus. So 2 root 2. And so into this is 3. And then this one into this is plus 2 root 2. And then this is plus 3 root 2. And then we get here minus 4. So this gives me 162 into minus 3 minus 4 is minus 7. Then plus 5 root 2. So if alpha belong to natural number, okay, that is fine, minus beta. So I guess this one should match with the desired option. So we get to see here alpha into root 2. So alpha will be 162 into 5. So alpha will be 162 into 5 will be my alpha. And now I want beta. So beta would be, let's find it. Beta will want this beta here. It's minus of just. So minus of 7 times 162 is my beta. Not minus, only plus. Only plus, because already they are given in the form of minus beta. So now we need alpha plus beta. So we can take 162 common and then 162 into 12. So 162 into 12 we can take it. So 160 into 100 will be 1600 plus 162 into 2 will be 344. So this gives me 1944. Okay, so the answer would be 1944. Let's go for the next one. So we have here all these are hyperbolas, and let's keep it the smallest even value of n so that eccentricity of hk is a rational number. So let's find out the eccentricity. So x square over root of 1 plus n square minus y square over square root of 3 plus n square is equal to 1. So hyperbola hk. Okay, for k equals no problem. So hk would be simply the square root of eccentricity of the hyperbola. So eccentricity of the hyperbola E is equal to 1 plus b square over a square will give me 1 plus b square is 3 plus n over this is going to be n plus 1. So I get here n plus 1 plus 3 plus 1. So 4 plus 2n over n plus 1. So e is going to be the square root of e square root of 2 times n plus 2 over n plus 1. So we want the smallest even value of n such that this should be a rational number. So we want rational number, that means this quantity should be a perfect square. So if we have a perfect square, then here square root of n plus 1 is also a perfect square, so that we get the same thing. That means if we have n plus 1 here, so we'll go for n is equal to 0 works, but we want the even value of n here, and n belong to natural, so 0 won't work. So we need to think of some other value. So we want to see here n plus 1 must be a perfect square, and n plus 2 into 2 must be even perfect square. So this fits into the criteria of some multiple of 2 then. So n plus 1, no? So 6 won't work. 7, no. We need to go even bigger because 2 into something. So square root of 36 not possible. 49 is 7, so n is equal to 7. 48 plus 1, 49. 48 plus 2 is 15 to 200. Yes, so that means n is equal to 48. Because for 48 we get this 49 and this is 50. So yes, that's a perfect square. Now what do we need? We need the length of, let us rectum of hk. Okay, k with the smallest even value of n. So k is basically smallest even value of n. So k is equal to 48. Okay. Smallest even value of n. Hk is the length of lattice rectum of hk. So length of lattice rectum of hk. Smallest even value of n. So hk. H48 we need to find out. So H48 will look like x squared over n is 48. So 48 plus 149 square, let's going to get here 49 minus y square over 48 plus 3 is 51 here. So we want eccentricity. So eccentricity would be e square is equal to 1 minus e square. So 51 over 49 plus. So we get here 49 plus 51 by 49. So this gives me 9 plus 1, 10. Okay, we can take this way. This is going to be 100 basically by 49. I think there was no need of doing this thing because we wanted a length of lattice rectum, so eccentricity was not required. But anyway, no problem. So length of lattice rectum HK will be equal to 2 times B square over A. So 2 times B square is 51 over A is 7. So now we want 21 into L. So L is equal to 2 into 51 by 7. So we want 21. So 21 to L. So 21 here. So 7 into 3 we get, that means 51 into 6. So we get 306 as the answer. So 21L should be 306.